Welcome to the project demonstration of TRIAC based fan speed controlling based on the temperature. So here, based on this temperature input from this LM35, so a microcontroller PIC 16F73 will read the inputs, and based on the temperature set values, we are going to set the on time and control the off time with help of this BT136 TRIAC, and that firing angle will be controlled through the in terms of voltage to this AC fan. So that parallelly we are going to control the speed of this fan. So for example, we here we set the limits are like below 35 degrees, so low speed, and 35 to 40 one speed, and 40 to 50, 50 to 60, and 60 above. So like this we are going to set the limits in for 5 stages. So here we are providing the 230 volts inputs to the whole cage. So parallelly that 230 volts given to the fan through this TRIAC board. Parallelly we have connected that, and next it is given to the main input voltage to this step down transformer, which will take 230 volts AC and provide us the 12 volts AC outputs. So to this regulated power supply board, it has a 3 stages. One is rectification, and next smoothing purpose filtration, and next regulation with help of this 7805. So after this rectification, nothing but here we are using DB107, which is the IC version of full wave bridge rectifier. So it will take 12 volts AC input and 12 volts pulsating DC outputs. So in order to remove the pulses, for smoothing purpose, we are making use of this 1000 microfarad capacitor. After that, 12 volts pure DC voltage input to this 7805 regulator, so which will take 12 volts DC and provide us the 5 volts DC outputs. So through this cable we are providing that to the microcontroller motherboard as a operating voltage. So on this motherboard we can see the 3 main important components. One is the microcontroller PIC 16F73, another is a reset to restart the microcontroller reset switch, and another is the steel plated one is a crystal oscillator, which is used to provide the 20 megahertz clock frequency to the microcontroller. The main purpose of this crystal oscillator is, so we have provided a set of instructions to read the inputs and to control the firing angle to this BT136 TRIAC. So these instructions needed clock pulse, 1 clock pulse per instruction, so that controller can execute 20 mega clock instructions per second, as we are providing 20 megahertz clock frequency per second. So here we have interfaced this LM35 to the A0 pin, and the TRIAC through this MOC 3033 optically isolated diac to the C0 pin, and LCD interface dates pin number B2 to B7. Here one more important component is like zero crossing detector. So the main purpose of this zero crossing detector is, so the system should know when we need to on the TRIAC and when we need to off the TRIAC. So that we are going to control the AC signal, so that the controller should know the AC starting waveform. So here we are providing the 12 volts AC to this. Again, same here we can see the DB107, so which will get the AC input and provide us the pulsating DC output. So whenever the pulse starts, means the sine waveform starts, then automatically the transistor will get switched on, and that was given as trigger input to our microcontroller at B0 pin. Then the controller will start and stops this BT136 TRIAC based on the input temperature with from this LM35. So parallelly we are going to display the so-called status on the LCD screen, nothing but temperature displaying that. So let us see demonstration. So initially it will display the welcome message, and then after, so as the temperature is below 35 degrees centigrade, so the motor rotates with very low speed, and once we are increasing the temperature, so next step 2, and above 50, step 3, and above 60 is a high speed for the motor. Right. In this manner we have set the limits based on the temperature, and that will be converted into the firing angle controlling, means on time, and parallelly going to control the off time by sending the duty signal in PWM. So when it cools down again, right, low speed.